In this video, I'm going to try and get my model trains to stop in N-gauge. How hard can that be? So I'm going to talk a bit about some of the things that I can do to make my train stop a little bit more accurately within the block. And there's a few different things I want to look at. But first of all, let's just find out where we are. So I'm going to run a train into the block and we'll see where it stops. You see it's just come here descending down the hill. It's just gone across the point work and it's entered into the block. Now it's going to slow down immediately. I've changed the settings a bit in order to make it slow down a bit more than I probably will when I actually run it. And that will just sort of accentuate the effect and give me a bit more time to see exactly what's going on. Now the way in which it's working out where to stop within the block is it knows the time at which it entered the block and it knows how fast it's asked the train to go. And from that it's worked out exactly how long it's going to be until it asks it to stop. Now it's going to stop, there we go. It stopped quite near the end of the block. I configured it to try and stop it 10 centimeters away from the end. So let me see exactly how close I got to that. Here's my tape measure. It's not the best angle to be honest, but you'll see it's probably around about 5 centimeters I expect. Let's see if I can do that a bit better. There we go, about 5. Now in order to improve on that, the first thing I need to do is to make sure that all the information in the system is accurate. There's stuff to do with the speed of the train, speed of the locomotive, and that's probably something I'll look at another time. But firstly, I want to have a look at exactly how long each of the blocks are, each of the track lengths. Now, I've worked out how long they should be when I designed it, but there's nothing like actually measuring what you've built. So I'm going to take a piece of wire here and just run it along the outside of the inside rail. Now that's not quite along the centre line, but I can measure how far away from the centre line it is and then do a little bit of maths to calculate what the error is going to be and add that to the total length. So there I've measured the end of the block. You can see the insulated rail joiner, and I've just put a little bend in the wire to mark where that measures up to. And then if I run it along my tape measure, get it nice and straight, I should be able to see exactly how long that is. There we go. So I'm in the iTrain editor now, in the block editor. And I'm just going to go and update my value. You see it's a little bit out of date, or a little bit inaccurate, but I can change it and make that a bit more accurate. There we go, save that off. Now, if I run another train, there we go, we're going up the hill and back down again. As we approach the bottom of the hill, I'm going to go across the point work and into the block again. Now the idea here is that it knows how long to run the train based on how long the block is. If the block is a bit longer than it was configured to be, then it's going to run the train for a bit too long and it's going to end up too close to the end. So now that I've updated the length of the block in the configuration, hopefully it'll do a better job of stopping it 10 centimeters from the end. It may well not be exactly 10 centimeters, and that'll be because there's other factors at play. You'll see also I'm pulling coaches. That may have an effect. It may be better to do this without the coaches. There we go, so we've stopped. And if we have a look with the tape measure, we're probably, what's that, 6.5, 7 centimeters out. Now, the next thing I want to do is to start having a look at my infrared detectors. And in order to do that, I need to turn on the power. So in order to be able to use infrared detectors for feedbacks, I need to modify my locomotive in order to make it work with the infrared feedback detectors. And the way I need to do that is to ensure that some part of the underneath of the locomotive is going to reflect the infrared light. So to do this, I've got my locomotive. This is my LMS Royal Scot 6100, and I've got some white paint. Here we go, enamel paint, some enamel thinners, paintbrush, and I need to think about which part of the locomotive I'm going to paint white. Obviously it's going to be on the underneath, and I don't really want to sort of splash paint all over the place. I certainly don't want to get paint on anything that might be close to the electrical pickups. So what I've decided I'm going to do is to remove the pony truck. That's the four wheels on the front. I'll actually remove that, and then I'll paint the underneath of that separately, so as not to make a mess of the rest of the locomotive. And so to take the pony truck off, I'm going to use my precision screwdrivers. Taken the pony truck apart. This is the underneath, so I'm just going to paint this section here white. So now it's reassembled, we can do one final test to see if it triggers the detector or not. There we go, and you'll see when the pony truck goes over the detector, it detects it, and the second light here comes on, so that's good. Now the next thing we need to do is to calibrate the train, the locomotive. And in particular, what we need to do is we need to calculate the offset between where it's detected and where the front of the buffers are. You'll see just here is the front of the buffers, but somewhere under there is the pony truck, and we need to find out how far ahead the buffers are from where the pony truck is. Now the way we can do this is to push the train forwards very gently until it first indicates just there. And now we can mark the position of the front buffers and see what the offset of that position is to the position of the detector. So that's the front buffer position, and that's the position of the detector. Now, the detector's just here, this black one, and the one here that's illuminated, that's the LED that's providing the light source. So I just need to measure that distance. And you can see there the distance is about 11 millimeters. And I also need to go through the same procedure with the locomotive pointing the other way round. So I need to measure the distance from the back to where it triggers the detector. Just there. And so that's my other offset distance from the detector here to the back buffer. And that's about 111 millimeters. So now if I go back to iTrain in order to set those configuration values, I can go to Edit, Locomotives, and if I choose the locomotive I want, which is the Royal Scot here, if I go to Options, you'll see here there are feedback offsets. Now, my infrared detectors are equivalent to a read contact. It's not quite a read contact. I have an infrared photodiode, and that responds to the presence of a white underbelly on the locomotive, but it's equivalent to there being a reed switch in the track responding to the presence of a magnet on the underbelly of the locomotive. So I'm going to use read contact, and I just set in here my values. So the offset from the front was 11 millimeters, and the offset from the back was 111 millimeters. There we go. It's as simple as that. So the next thing that we need to do is to measure exactly where these optical detectors are within the block, and then configure that in the software. So in order to do that, we'll use the old trick of measuring with the piece of wire. Start here where the detector begins, where the detector is, and run the wire along the inside of the rail again, all the way to the end of the block. Whoops. I'll put a little bend in there. and so that's 875 millimeters. Okay, so I'm back here in Train Controller, and I need to configure up this feedback. So the first thing I can do is go to Edit and Feedbacks. And in fact, I've already set this one up, so let me just show you here. This last one in the list, it's named SY4FB2, so that's staging yard 4, feedback number 2, and that's the first optical detector in the staging yard lane 4. Now the key thing here is you'll see it's set as a read contact. If it was an occupancy feedback, then it would have a length, because the length that's the length of the track over which it'll detect current. But these optical detectors I'm setting up as read contacts, because that's the most close sort of analogy that there is in the software to what I'm actually using. And you'll see here it's got an address. It's address number 34 in this case. So that's all set up. Obviously I can put a comment, but I haven't. So I'll apply that. So that's all saved. And then I need to configure up where that detector is within the block. So if I go to Edit, now the block we're talking about is staging yard lane 4. There we go, SY4, staging yard 4. And here you'll see there's a list of feedbacks. Now the first feedback, that's the occupancy detection. And the second feedback is the optical detector. And you can see here I can set the position of the optical detector. Now in fact, again, I've already set this up. We measured it was 875 millimeters. I've added an extra 2 millimeters because I measured along the outside of the inside rail rather than the center line. So I need an extra little bit of fudge factor just to account for that. And I've calculated that should be around about 2 millimeters. And so here I'm saying it's 877 millimeters between the optical detector and the end of the run, and so this is the distance from the start if we're heading in the opposite direction. So if I set that and it's calculated that's 92.8 centimeters from the beginning. So that's the absolute position of the optical detector within the block. And I can save that, and then that's all set up. You'll see here I've configured up the optical detector here on the feedback on the actual map. So if I right click on there, you can see that is feedback SY4FB2. Okay. So now I should be ready to have another run and see if it stops the locomotive slightly more accurately. Okay, so we're ready to have another run to see how accurate this is going to stop. This time we've enabled the optical detectors. So I'll move the Royal Scot into this block, tell it to route, and it's set up the route. Here we've got the locomotive started running. So it's into the staging yard lane now and slows down. It's just about to pass the optical detector. There you see it enabled it. So the fact that it passed the optical detector means that the system knows when it was halfway through the lane. So that should enable it to get it to stop more accurately. But let's just see where it stops. Using the tape measure, we can see that has now stopped about 8.5, 9 centimetres from the end of the block. So that's an improvement on the 7. So you'll see here, just towards the end of the block in the staging yard, I've added another optical detector. You can see there it's turned on. That's about 25 centimetres away from the end of the block. And so after triggering that, the locomotive's only got to travel another 15 centimetres before stopping. So that should give me a much more accurate stop position. So you'll see here, just towards the end of the block in the staging yard, I've added another optical detector. You can see there it's turned on. That's about 25 centimetres away from the end of the block. And so after triggering that, the locomotive's only got to travel another 15 centimetres before stopping. So that should give me a much more accurate stop position. And that is exactly 10 centimetres. Well, rather amazingly, that all worked. I'm pretty pleased. I've been working for a long time to get these optical detectors to work, but also to do what I want them to do, which is to improve the accuracy of the stopping positions of the locomotives within the block. I know I haven't produced any videos for a while. I'm sorry about that. That's just the way that life is. But now that I've done this, I think I can make some progress on trying to complete the circuit of my railway. I hope you'll join me next time.